Bismillahirrahmanirrahim. This video is about question number 7.51, a step response of an RC circuit. And this is from the book Electric Circuit by James Nilsson. And for this, a student has specially requested. So let's see. Before we start, let me just recall this. I have been repeating in my so many videos, these three stages of time. If this is the input, which is 0 up to this point, and then suddenly we apply let's say 1 volt signal to an RC circuit, then there will be 3 stages. One is before 0, we call this t less than 0. The other is immediately after 0, we call it t greater than 0. But actually keep in mind that this is the transient period. So the capacitor is charging in this region, and then after 5 tau this becomes steady state, and we call that as t infinity or t greater than 0. So this will be using, and keep this point in mind. Now the question is, the switch in the circuit shown in figure has been closed for a long time. Now this switch, this has been closed before t is equal to 0, and it is opening at t is equal to 0. So keep that in mind. So closed for a long time before opening at t is equal to 0. And then we have to find for t greater than equal to 0, we have to find these parameters: V0t, I0t, I1t, I2t, and I10t. Now V0t or Vt is always the voltage across the capacitor. So we have to find this voltage. I0t given here is the current through 60k resistance. Then next is I1t, this current, and then is I2t, and then I10t. So once we have found I1t, we just put t is equal to 0. So this will be our strategy. So the first thing, keep in mind, keep the circuit in mind, and this is the formula that we use for step response RC circuit. Now, what is step response means? You can see that this voltage is applied to this circuit the moment this is open. At t is equal to 0, this is open. So this current, not voltage, I'm sorry, this current is applied to the circuit. So that means suddenly we are applying input. So this is called the step response. And then this is R and C circuit, so step response RC circuit. Now what we need to find the voltage output or voltage t at any time is, first of all, we have to find the V0. This one is the V0, that is the voltage here. We need to find that. In this region we find tau. This tau we'll find. And in the third region we'll find V infinity, this value, this value. So this is how we'll proceed. Okay, in the book, end of the chapter, this answer is given, so it will be easy for us to verify whatever we are doing. Okay, so the first one is V0t, that is the voltage here. And so from here you can see we have to find V0 for t less than 0. So what will be the circuit for t less than 0? The switch, keep in mind, it is closed and it is opening at t0 or at t after 0. So that means our circuit will be closed like this. And when this is closed, this whole current is passing through this. It's not going ahead because of the short circuit. So the complete current will just loop around. That means the capacitor will not charge to any value, any voltage, any signal. And so we can say from here that since no current is flowing through the capacitor, the charge will be 0. So we were here, since no current is flowing through this portion, therefore the capacitor will not charge, and therefore the voltage drop across the capacitor will be zero. So we'll write V0 0, or we can just say that it is V0 is equal to 0 volt. So this term we have found. Now we need to find the tau, and then we need to find V infinity. So for tau, we go to the t greater than 0. At t greater than 0, the switch is now open. And as we mentioned that this equation we have found already V0. So first we'll need find tau during the transient period. And the formula for tau is R equivalent multiplied by C, or it is also called R Thevenin multiplied by C. Now I hope you remember how to find the Thevenin resistance. For Thevenin resistance, first of all we remove the load. So this is the load we are removing, and we also put the voltage source or current source equal to 0. Now for voltage source to make 0, we short circuit. For current source to make 0, we open circuit. So we have open circuited the current source. We can further simplify by eliminating this portion. So our circuit will now look like this. And we look from the load side to find out the R equivalent. If you're looking from the load side, you can see these two are in parallel in series with 8. So we can say that R equivalent is 8K, 8 in plus parallel of 15K and 60. And solving, this will be 8 plus 12 and equal to 20K. So R equivalent is 20K. And now we can find tau. R equivalent C is 20K multiplied by 500 nanofarad. So writing the values now, 20K is 20 10 raised to the power 3, 500 into 10 raised to the power minus 9. So it will be 10 10 raised to the power minus 3, or 10 millisecond. Okay. Now we will find V infinity. We are still in question number A. V naught we have found, tau we have found. So we need to find now V infinity is for t greater than 0 or t infinity. Now what happens to the circuit? The circuit becomes a steady state, and during a steady state, the capacitor is fully charged, and then it behaves like an open circuit. So that is why we show it with an open circuit, and we'll calculate this voltage V infinity. Now V infinity, because there is no current flowing in this circuit, capacitor is open, so there will be no voltage drop across 8K. So whatever is the voltage drop here will be appearing across this. That means we can say that the V out infinity is actually V60, the voltage across the 60K resistance. And V60 will be actually I infinity multiplied by 60 ohm. And how much is I infinity? You can find from the circuit the current by CDR, current division rule. This is the current, total current, dividing into two parts, one and the second. So we know that the total current is divided by the total resistance, 15 plus 60, multiplied by opposite arm. So we want to find the current here, so we multiply by the opposite arm, that is 15K. So the current I naught infinity is 1 milliampere. Now that we have found I naught infinity, so multiply by 60K, we'll get the V infinity. So I naught infinity into 60K, 1 milliampere into 60K is equal to 60 volts. So V infinity we have found 60 volts. So all three parameters of the VT we have found. So Vt is, now we'll just plug in the values. 60, this one 0, 60, e raised to the power minus t over tau. Tau was 10 into 10 raised to the power minus 3. So solving this, we'll get 60 minus 60 e raised to the power minus 100 t volt. So this is the first part we have solved. And this is the answer given at the end of the book. So we got the same answer. Okay, so we were here, we have found V naught T. Then let's go to the part B. It says I naught T. Now this one we have to find for time T. Earlier we had found it for infinity time. Now we have to find it for time, any time T, IOT. And I'm just eliminating this to keep the circuit simple. So this is the one. And couple of things I have added. I am naming this current to be I3T, and also I'm naming this node as to be V1T. Remember, these two nodes are same because of this short circuit. And now we'll take help of the nodal equation to find this current. Now by nodal analysis, current entering is equal to current leaving. Now in this circuit, you can see this current is entering, I3 is entering, I2 is leaving, and I0 is leaving. So we'll write the source 5 ampere entering plus I3T entering is equal to I2 leaving, I0 leaving. Plugging in the values now, 5 ampere. How do we write I3T? You can see it is starting from here. The current is starting from here going to V1. So this point is ground or 0. So 0 minus V1 divided by 8. 0 minus V1 divided by 8. What do we do with this voltage? Now this voltage is contributing current in the same direction as I3T. Therefore, this voltage VOT will be written as positive VOT. So positive VOT. So this is the numerator divided by 8K, and I2T. I2T is this same point, V1 divided by 15, and I0T is V1 divided by 60. Now we'll solve this equation taking LCM and then simplifying and further cross multiplying, further simplifying, and now in this equation we'll put the value of V naught. We know the V naught, we have calculated, so we'll plug in that value and keep on simplifying to find V1T. So if you find V1T, we can find I0T. So V1T from here, and this dividing will be 60 minus 36 e raised to the power minus 10t, 100t. And so now we can find IOT is V1. This is V1T divided by 60K. So plugging in this value divided by 60K, so the answer will be 1.1 minus 0.6 e raised to the power minus 100 milliampere. Remember, because we are dividing by K, therefore the answer will be in milli. And this is the answer given in the book. So we have the same answer. So these are the parameters we have already calculated. Now let's see part C is I1T. Now this is I1T. And again, if you look at the circuit, you can easily see that by KCL, current entering this node I1, I3 is equal to I0 leaving. And from here, we are actually interested to find I1. So we move this to the right. Moving to the right, we know the value of both. Sorry, we don't know the value of I3T. So I3T will calculate from here again. 0 minus V1 plus this voltage, as we have discussed in the previous slide, divided by 8K. This will be I3. And this, we put the value of V1 from here, and also we put the value of V0. And further simplifying, we get I3T to be minus 3 e raised to the power minus 100T milliampere. And now we will plug in here, in this. I0T we already had calculated, I3T we calculated here, so plugging in and simplifying, we get this answer, and this is the answer given in the book. So part C is done, and now part D is I2T. So I2T is now easy to find. From here you can see I2 again, this current is entering and these two leaving, so we can write 5 is equal to I2 plus I1, or we can write that 5 minus I1 is I2. I1 we had just calculated here, so we'll plug in that value, and solving we get this to be answer of I2T. And this is the answer given in the book. And finally, we'll find I10. We know the value of I1, so we'll just put T is equal to 0 here, and this, putting T is equal to 0, we get I10, and this will be multiplied by 0, so this will be e raised to the power 0, and we know e raised to the power 0 is 1. So this, and finally the total answer will be 3.4 milliampere. So I hope you have been able to follow this. A slightly tricky question, but if you follow step by step, it will be easy. Please let me know through your feedback. Thank you. Okay, and this is the answer given in the book, so we got the same answer. Thanks.